Welcome to part 5 of our series on building a Zelda-like game in Phaser 3. To keep our code flexible and reusable, we're setting up a component system. In this video, we'll build our base component and input component, laying the groundwork for scalable game logic. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Let's get started and structure our components. Now that we have our basic input functionality working, before diving into moving our player in the game, let's take a moment to set up the structure we'll use for our game components. In our project, components will be small reusable pieces of code that extend the functionality of built-in game object types. This modular approach will give us the flexibility to attach various components to different game objects, such as the player, enemies, or items. By using this pattern, we'll be able to enhance any game object with specific behavior while keeping our code organized and scalable. However, to make this system work effectively, we need two key features: storing references to component instances on our game objects, and checking for specific component types on any given game object. To handle this, we'll create a base component class that all components will extend. This base class will provide the shared functionality needed to register, reference, and manage our components across the game. Create our base class. In our source code, let's go into our components folder. Let's make a new folder. We're going to call this game object. Let's make a new file, and we'll call this base game object component. So let's export out our class. We'll do export class base game object component. So for our component, we'll need a reference to our phaser scene that our game object belongs to, and we'll need a reference to that game object itself. So we'll add in two properties. We'll do protected, because this is our base class. We want all of our other components to extend it. So we'll make these protected so these properties are accessible in those classes. So we'll do scene. This will be our phaser scene. And now we'll do protected, and we'll do our game object. And for our game object, we'll want to support multiple types, like our sprite and image. For this, we're going to define a custom type that's going to list the available game objects types we support. So we're just going to call this game object. Let's jump over to our types file real quick and we'll define that. So under our common folder, let's do export type. We'll do game object. We're going to set that equal to our phaser, our game objects. We'll do sprite, and we'll also support images. So we'll do phaser, game objects, we'll do image. Let's import phaser in our file. So we'll do import star as phaser from phaser. Let's copy that statement. We'll jump back over to our component class. We'll add that in at the top. Now let's import our game object type. We'll add in our constructor, and we'll expect one argument. This will be our game object, and we'll type it to game object. So now we can set our properties. So we'll have this.scene will be equal to our game object and the scene property on our game object. And then we'll have our game object equal to our game object instance. So now for our class, we need a method that will allow us to provide a game object, and then we'll return the instance of this component if it exists on that game object. To do this, we'll need to store a reference of this component instance on our game object, and then that way we can use that same method to look up if that component exists. So let's make a new method. We're going to call this protected, and we'll do assign component to object. So for this, we'll expect our object, and this will be a game object, and we won't return anything from this method. So now to store a reference to this component on our object, we're just going to add that as a property. To do that, we'll reference our object, and now we'll just add in a new field on our object. And so we're just going to reference our constructor name. So we'll do this, we'll do our constructor and name, and then we'll set equal to this instance of our game object. So now up in our constructor, we'll just call our new method, and we'll pass in our game object. Now that we're storing a reference of our component instance on our game object, we can now add in a method that will allow us to take a game object and see if that object actually has an instance of this component. For that, we'll use our static keyword, and we'll do getComponent. Now for our method, we're going to select one argument. This will be our game object. And so now we'll just want to return our game object, and then we'll use the same lookup here for that property name. So because we're using the static keyword, we can't use this.constructor, and so we want to use this.name. So I'm going to copy this string here, we'll paste it, we'll remove constructor, let's do this.name, and we'll save. And now we're just going to add in our type information. So when we call getComponent, we're going to expect the type of the component we're looking for to be provided, and then that way we can return that type, and then that way our code will be typed properly. And so by using the static keyword here, This is going to allow us to use this method from our class without having to create an instance of our class. Similar to our getComponent method here, we'll want to have a method to allow us to remove a component from a game object. So I'm going to copy this here, I'm going to paste it, and we'll do remove component. For this, we won't need our type information since we won't return anything. We'll just do void, and now we want to do delete to remove this property from our game object. Now that we've defined our base GameObject component class, we're going to create our first component instance. For this, we'll make a new component called our controls component, and the purpose of this component is to provide an input component to our game objects. Currently, our player is set up where we pass in an input component instance and we're referencing that directly in our code. Now, the downside of doing that is if we ever want to swap out our input component that our player is using, we'll need to add methods to our class to do so. A good example of this is if we ever want to support other input types like gamepad. If we ever had an options menu where a player can switch between the two, we would need to dynamically update our player class to use that new component instance. By placing our input into a new controls component that will extend this class here, this will allow us to abstract that away. And as long as we can reference our controls component, we'll be able to do things like swap this out on the fly. Another good example is, let's say if we have a secondary game object that might follow our player. Maybe this game object has a simple AI where it'll just follow along and help the player, but maybe we add in support for 2-player. And so when a player joins, we'd want them to take over that game object, and so we need a way to swap out our input component to the input that's being provided by player 2. And so by moving this logic to its own component and abstracting this away, we'll be able to support different use cases like this in the future, and it'll make our game more scalable. To do this, let's jump back over to our code. Under our game object folder, we'll make a new file. We're going to call this controls component. So in our class, let's export our class. We'll export class controls component. This is going to extend our base game object component. And so on our class instance, we'll need a property to keep track of our input component. So we'll add in a private property. We'll do input component. We'll add in our type to reference our input component. We'll add in our constructor. And so we'll need our game object. And then we'll need our input component. And so let's call super. We'll pass in our game object. And now we'll store our reference to our input component. And for the time being, let's just add in a getter, and we'll do get controls, and we're going to return our instance of our input component. So now that we have our new controls component, let's jump over to our player class, and we'll create an instance of this. So on our player class, let's update our property name. So we're going to do controls component, and we'll update our type, and we'll do controls component. So now down our constructor, we'll update our reference. We'll have controls component. And so instead of doing config controls, we're going to create a new instance of our component. So we'll do new controls component, and we'll reference this from our game object. And now we'll do our configuration, and we'll do our controls. So now we just need to update our update method. So down in our update method, let's grab a reference to our controls. And so we'll do const controls. It's going to be equal to this, our controls component. And now we'll reference our controls, and we'll update our references down here. So instead of doing this.controls, we'll just do controls is up, down, is down, down, is left, down, and then is right, down. All right, so now if we save and our browser refreshes, we should now be able to provide our input, and our game should work the same way it did before. I know we just added a lot of code, and you might not see any immediate changes in our game's functionality, but trust me, this structure will pay off as we start adding new game objects and the game grows more complex. By setting things up this way, we gain several key benefits. Reusability, we can easily attach components to any game object and reduce our redundant code. Modularity, we can break down our complex behaviors into smaller, manageable pieces of code, making the code easier to maintain and extend. Flexibility, we can quickly add new features as our game expands by simply creating and attaching new components. This foundation will keep our game development process smooth and scalable as we move forward. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching, and I'll see you in the next one.